Alright, this video is going to explain some Algebra 2 concepts with regards to rational expressions, rational equations, and domain of functions. Alright, so let's talk about the difference between a rational expression and a rational equation. The difference is simply the equal sign. Okay, so if you look at some of the problems that I'm going to be doing for you, there is no equal sign, and it's just two fractions, and you have to add it together. Now, before I do this, I want to make it clear that you've done this before, like in 5th or 6th grade when you learned regular fractions. It's no difference, okay? So what you want to do is, first of all, look at this expression and realize that they're just two fractions with two different denominators. I might as well just write it like this: 3 over p plus 6 over q. Whatever p and q is, if you want to find the common denominator, you need to multiply those two numbers together. That's your basic algorithm there. But I'm going to do it like this, okay? Since p is already there, I need a q, so I'm going to multiply a q here and a q on top. And on this side, since I already have a q, I need to multiply a p and a p. And if you notice, q over q basically equals the number 1. So technically we are actually multiplying by the number 1 so that the fraction 3 over p does not change. So 3q over pq is an equivalent fraction for 3 over p. Again, I'm going to leave the 6 right up here. And so now my new fraction is 3q over pq plus 6p over qp. And you realize once you have a common denominator, you write it as one fraction, pq on the bottom, and you just add the top. Okay, so basically that's what we're going to do. Now this is obviously very simple. We're going to do the same thing with something a little bit more complex. And you have to keep in mind that it just looks more complicated, but it is not different. To avoid any more confusion, let's put a parenthesis around each of the denominator and consider a parenthesis as a single number. Even though you see an x plus 4 there, it represents some number in the real number system. Okay, and there are two different numbers, so the common denominator would simply be, like in this case, it's a p and a q, and all you have to do is multiply p and q together to get the common denominator. But before you do anything, when you work with rational expressions, and by the way, for those of you who don't know what rational expressions are, it's a fancy word for fractions, okay? But it's not just numerical fractions, it's fractions with variables on the denominator. That's what makes it a rational. For instance, if you see something like 2/3 x, that's not a rational expression because the variable x is not in the denominator. It'll turn into a rational if you put it like this, 2 over 3x, okay? So for every rational expression and also equations, the first thing you want to do is always state the excluded value. The excluded value is no different than the word domain. And the idea here is every expression in math, or every expression in different types of expressions, they all have some kind of a limit or an unlimited ability to take in values for the letter x. You have all these numbers on the number line, and the question is, can you plug in a particular number here, or can you not plug in a particular number there? With regards to fractions, fractions hate zeros. So we never ever want to have a 0 on the denominator. And if you take a look at the fractions right there, you realize if this x right here is -4, -4 plus 4 will turn into a 0. If this x was a -5, it will also turn into 0. And whenever you have a 0 on the denominator, it's basically undefined, and you don't want that. So the first thing we ask is, what values do I exclude? We simply state what x should not be. X should not be -4 and -5. Now, once you've established that, you can go on. So let me zoom out here for a little bit. Let's rewrite the equation right over here. 3 over x plus 4 with the parenthesis, 6 over x plus 5. And again, just like the way we would do any fraction, 3 over x plus 4 plus 6 over x plus 5. And now I'm going to multiply by the identity, 1. Now, you probably never seen this, but that's what we're doing. We're using the identity property of multiplication to turn this equation, or this expression right up here, into something equivalent to that one, but in a different format. What I'm going to do is erase this 1 and rewrite it as this. This is my other factor that I need, so I'm going to put x plus 5 here on the bottom, x plus 5 here on the top. And you notice that that equals 1. But we're going to leave the expression like this. And on this one, we're going to erase that and put the other factor, x plus 4 over x plus 4. And this is your common denominator. Let me move to the right. And so what you're going to do is basically rewrite this as one fraction, 3 parentheses, x plus 5 over x plus 4, x plus 5, plus 6 parentheses, x plus 4 over, again, x plus 4, x plus 5. Once you have a common denominator, you combine the fraction into one single fraction. You don't repeat the denominator. I know some of you have done that. You just leave it the way it is, and you write x plus 4, x plus 5 on the bottom, and on the top. Now here, I want to caution you, do not distribute, okay? Just leave it the way it is, and just write it exactly the way you see it, and then afterwards, distribute it out. Now the reason for this is just to be cautious, because when there's a negative sign, students normally leave out the distributive property for the second term, and they end up writing something like negative 6x plus 24 rather than negative 6x minus 24 if the sign was a negative. So you want to practice good habits when you write these problems, when you do these problems. All right, so now the denominator, you always leave it in its factored format. You do not multiply it in. But the numerator, you want to distribute everything and combine all the like terms, and then ask yourself if there's anything we can cancel out with the bottom. So right here, this would be 3x plus 15. And here it will become 6x plus 24. And then you combine the like terms like 3x and 6x, that will become 9x. 15 plus 24, that will become, let's see, 39. And the bottom will stay the way it is. And now from here, you have to ask the question, if I factor it, will it produce a like factor on the bottom where I can cancel out? If you're not sure, just try it out. You can divide, or you can factor out a 3 like that. And this will be 3x plus 13. And you notice nothing's going to happen. So basically, you can either present your answer like this, but most of the time, teachers will want the answer to be this. Now, you're not done. Go all the way back to the top and make sure you restate the excluded value. X cannot equal negative 4 and x cannot equal negative 5. So you include that with your answer. X cannot equal negative 4 or negative 5. And so all of this is your final answer. All right, let's try another one. Now this one's a little bit more complicated. It's different than the one we've done, because if you notice, the denominator can be factored. Now, before you start factoring, again, the first thing we want to do is realize that these two equations, or these two expressions, have the exact same denominator. Okay. Once you have the exact same denominator, you can immediately combine the fraction into one fraction. So there's no need to get common denominator. But as I told you before we do anything, we have to always state the excluded value. So let's take a look at the denominator, x squared plus 3x, and let's ask ourselves this question: when will this denominator turn into 0? Now again, I'm not trying to solve this. I just want to know what's going to cause this expression to become 0. To do that, you set it equal to 0 and you solve it. So you write x times x plus 3, you factor it out. And we use the zero factor theorem. When you have factors or terms that are multiplied equaling 0, you set each factor equal to 0. The first one, x equals 0. The second one, x plus 3 equals 0, x equals -3, x equals 0. So what does this mean? It means these two numbers will turn this expression to 0, which means it's going to turn the denominator to 0, which we don't want. So these two terms become what we call the excluded value. Okay, x should not or must not ever equal 0 or -3. Okay, now we've stated the excluded value, we can continue. So again, we look at the fraction and we realize it looks pretty ugly, but the denominators are exactly the same. So all you have to do is basically combine the fraction into one expression. So the denominator stays exactly the way it is. Oh, let me take a step back. We always want the denominators to be factored out. So here's the factor term right here, x times x plus 3. So we're going to use that and write x times x plus 3. And the numerator, again, we're just going to write it exactly the way it is right up here. X squared minus 2x plus x squared plus x. And again, simplify the numerator, combine like terms. You can combine the x squares together. That'll become 2x squared. And the negative 2x, positive x, those are like terms. That will become negative x. And again, you ask the question, should I factor the numerator and will it cancel something out with the denominator? Now, if you can't tell, just give it a try. So you realize that both of these terms have x in common. So you pull that out and this becomes 2x minus 1 over x parenthesis x plus 3. And voila, you have the same terms, top and bottom. They're factors and you can cancel it out. And so your final expression will be 2x minus 1, x plus 3. And again, don't forget your excluded value. X cannot equal 0 and x cannot equal -3. So this right here is your final answer. All right, let's move on to another example. Again, we're just going to look at more expressions, but a little bit more complicated. Again, if you have a hard time just kind of seeing the simplicity behind this, just take a step back and realize, oh, it's just a 4 on top and one big, expression on the bottom, which represents just one term. And you realize there are different denominators. Well, we're going to first look for the excluded value and then figure out how to make both fractions end up with the exact same denominator. So we know for here, the excluded value has to be -3. Okay, so x must never equal -3. We want to exclude that from, ever including this into your x's, because this will turn into 0 if you plug in -3 right there. How about this one? Well, x squared plus 6x plus 9. When will this ever equal 0? Well, again, if you've done algebra 1 carefully, well, you will just factor that out and set it equal to 0 and figure that out. So how do you factor this? Now, some of you have, different lessons that you've learned from school, the X method or the area method. I just do it in my head, put 2 parentheses down. And this only works when you have a 1 in front of the x squared. If you have another number, I actually rather just use the x method. But here, you just take 2 factors of 9, 2 numbers that multiply into 9, where those 2 same numbers will add up to 6, 3 and 3. So you put 3 and 3, 3 plus 3 is 6, 3 times 3 is 9, and there you go. Now, every time I factor, I make it a habit to always double check. So x times x is equal to x squared. 3 times 3 is equal to 9. And then to check the middle term, you multiply the outside 2, add and multiply, well, you multiply the outside 2 and then add it to the product of the middle 2. So 3x plus 3x is equal to 6x. This is right. And notice they're the exact same factors. So x plus 3, you can write it this way as well. And so obviously, x cannot equal what? -3. That's basically the excluded value for this guy. So there's an excluded value for this one as well as this one, and it turns out they're exactly what? They're exactly the same. Now again, it's not that it's obvious. We just had to go through, even though it's the same one, you have to go through the procedures to figure this out. Finally, let's start the problem. So let me erase this little x right here. So let's rewrite this with our factor denominator. This will be 4 over x plus 3. Now I'm going to write it as x plus 3, x plus 3. And the second one will become 4 over x plus 3. So obviously, this guy needs an extra x plus 3 to become the exact same denominator as the first fraction. So what are we going to do? We're going to use the identity property. And again, you can multiply 1 at any time. This time, that number 1 is going to be turned into x plus 3 over x plus 3. So combine the two, and what do we have? We have x plus 3, x plus 3, and we're going to combine this one, 4 plus 4 times x plus 3, and then we're going to distribute it out. 4 plus 4x plus 12 over x plus 3, x plus 3. Again, just simplify the numerator. 4 plus 12 is 16, so 4x plus 16 over x plus 3, x plus 3. And again, the question is, can I do something with the top? Well, 4 times x plus 4 is your factored form, and x plus 3, there's nothing in common, so we should just leave it like that and include the excluded value. X cannot equal what? -3. Okay. Do I have one more? I think that's about it. Oh wait, there's a couple more. All right, now here's an ugly one. Okay, it's just, big and ugly and gruesome, but it's the same thing. It's just, you just take it one step at a time. There's 3 fractions now with different denominators. We have to obviously figure out the excluded value for this one, and what? That one. And again, you should recognize that you can factor this. Once we figured out the excluded values, we're going to combine all the denominators together and make sure every fraction has the exact same denominator, multiply by 1, get the numerator as well, combine it, and we're home free. All right, so excluded value for this one, x cannot equal -1. That one, x cannot equal -2. What about this one? Again, just factor it out. This will become x plus 2, x plus 1. Okay, how do I do that? You go to the last number 2, and you ask, what are the numbers that multiply into 2? 2 and 1. 2 and 1 adds up to 3. There it is. Magic. Okay? All right. Now, you might be looking at the top and thinking, oh, I should factor that. No. Yes, no. Okay, no. Because what you want to do is, once you combine the numerator, you're going to add and subtract all the like terms. So if you factor it, now you're going to have to multiply it out again and then combine all the like terms. So that's going to be extra work. So again, don't factor the numerator until the very, very end. Just factor out the denominators, look for your common denominator, and then you'll see how to proceed. All right, so from this one, x cannot equal -2 and x cannot equal -1. So we have -2 and -1 if you combine all of those. So x cannot equal -1 or -2. So let's just box that. Okay, let's rewrite the fraction, this one. Now there's a lot to write, so my hand's getting tired, but we will endure. Okay, so let's write this as 4x squared minus x minus 6 all over x plus 2, x plus 1. And the second fraction is 3x over x plus 1. And I'm going to put some space in between so that I can write equivalent fractions by using the identity property of multiplication. Okay, so what do we have here? All right, so x plus 2, x plus 1, that's your common denominator. If this guy had an x plus 2 and that guy had x plus 1, everybody will look the same. So we're going to multiply this by x plus 2, top and bottom. And this one, we're going to multiply by x plus 1. So x plus 1 and x plus 1. And I think you understand how this works out. All right, so once I have all the denominators exactly the same, again, I'm not going to do anything with the numerator because I'm worried about this little negative sign. I have too many students making mistakes on this, costing them, between an A and a B. So just my recommendation is just do it the way, do it safely, and you'll never regret it. Okay. All right. So x plus 2 and x plus 1 is on the bottom. The numerator, we have 4x squared minus x minus 6 minus 3x parentheses x plus 2 plus 5x plus 1. And now let's distribute it out carefully without missing anything. 3x squared minus 6x plus 5x plus 5. And then, oh, I forgot to write the first few terms. 4x squared minus x minus 6. Okay, so x plus 2, x plus 1. Tiring, huh? All right, let's get rid of those two. 4x squared minus 3x squared becomes x squared. So cross it out. Again, always looking for the most careful way to do math, so you don't make careless mistakes. All right, what do we have here? We have an x right here, an x right there, an x right there. So I'll do these two first. Negative 6x plus 5x produces a negative x. Negative x combined with this negative x becomes negative 2x. And once I finish those, I cross those out. What do I have? I have a 6, a negative 6, and a 5, which adds up to negative 1. Voila. And this becomes x plus 2, x plus 1. And is that the right answer? No, I think I made a mistake somewhere actually. Let's see, let's double check. All right, so 4x squared minus x minus 6, is that right? Oh, okay, so look at that. Right here, I miscopied this, a positive and negative sign. So I'll put this in red. Again, really got to be careful with these because there's so much numbers. It's actually pretty easy. It looks complicated, but it's easy to make a mistake. All right, so is that it? 6, 3x, 5. I'm just double checking everything. So we gotta make sure this is plus. And the distribution, let's see, I wrote this carefully. Yep, and then, all right, over here, let me erase these marks and start over. Okay, so this is the benefit of having an iPad with a OneNote. You can just delete all this stuff. Let's see, 4x squared, oh, right here, plus, okay, right there. Let me see if I wrote it. Okay, negative 3x minus 6x squared plus 5x. Okay, all right, so now let's try it again. Wait a minute, wasn't there a squared somewhere? Ooh, right here. 3x squared. Okay, so 4x squared minus 3x squared becomes x squared. And that's done. And we have a x negative 6, that's negative 5 plus 5, that cancels out. So nothing on that. And then negative 6 plus 5, we have negative 1. Whoo, here we go. And then, again, this should be a big, like, red alert. Anytime you see a difference of squares, something squared minus something squared, even though it's a 1, you can look at it as 1 squared. It's the same thing, right? 1 times 1 times 1 is just 1. All right, so you can always factor that into x minus 1, x plus 1. You have to know this. This is so important. In the denominator, x plus 2, x plus 1, and you realize you have common factors here, here, and the resulting expression now is x minus 1, x plus 2, and we go back up to our excluded value. X cannot equal negative 1, x cannot equal negative 1 or negative 2. Now you might be wondering, well, we only have 2 on the bottom in the resulting expression, so shouldn't it just be negative 2? And the answer is no. And this is really for calculus students. When you take limits, you have to do all this stuff. You're basically going to take limits of these expressions. When you cancel something out, it doesn't mean that it just disappears. On the graph, you're going to have what you call a hole. And I'll save the explanation for that later. But what I'm just saying is this. It matters what you start off with. So you want to include that in your final answer, even if your final expression doesn't seem like it needs this excluded value here. Okay. All right. So anyways, just write that in there. Okay. So that's it for that one. And should I do one more? I really don't want to. I'll just factor out the bottom, give you the excluded values, and then just kind of move on. All right, so notice this right here is your difference of squares, a squared minus b squared. If you don't see that, or if you can't see that, watch this. So 2x squared, a squared minus b squared. A squared minus b squared is what we call the difference of squares, and it always factors out into a minus b, a plus b. One of them, the most used factor theorems in math. All right, so how do we factor this out? This becomes 2x minus 1, 2x plus 1. That's the denominator for the first fraction. So if you set this equal to 0, 2x minus 1 equals 0, 2x plus 1 equals 0, you get x equals 1/2, x equals negative 1/2. I just skipped a step. I moved the 1 over here, divided by 2, okay? So those are my first excluded values. The second one, you just factor out an x, so it would be x parenthesis 2x minus 1. Now the last one, as I told you, if there's a number in front of x squared, can you do the quick method that I did before? You can. It just takes a little bit of a guess and check, but if you mess up, you just take longer than you need to. So just either use the area method, the 4 squares, or the x method, and you're good to go. So how to use the x method, for those of you who might have forgotten, you multiply the first number with the last number. 2 times 2 is 4. Now some teachers just write the number 4 up there, but I like to put the whole term, 4x squared. And then you put the middle term, 5x, on the bottom. So it's no different than just writing it like this, 4 and 5, where you look for two numbers that multiply into 4 but add up to 5. You multiply to positive 4 and you add up to a positive 5. You have choices between 1 times 4, 2 times 2, and obviously 1 and 4 will add up to 5. So we're going to put 1x, 4x, or I guess in this case, just 1 and 4. Now the reason I like this better is because these two numbers are going to replace this expression right over here, and that's the idea. You want to rewrite this expression. It'll be 2x squared, and I'll use green. So plus x plus 4x plus 2. Notice, x plus 4x is equal to 5x, which is the middle term. So we're just basically rewriting this into this where it's actually factorable. So we factor by grouping. What does that mean? You group the first two and you factor separately. This will become x parenthesis 2x plus 1. Don't forget the plus sign, and then you factor out a 2 from both of those, and this becomes 2x plus 1. When you have these two looking exactly the same, you know you're on the right track, and you can factor those two out. So you write this as 2x plus 1 and x plus 2. So that's your factor for that expression. So 2x plus 1 and x plus 2. Okay, so now the question is, what's your common denominator? Okay, so I guess I'll just do a little bit more because this one definitely looks complicated. So again, you want to make it look nice. Okay, when you write these out, organize it on your paper and use as much space as you want. Well, not too much, or else you'll just go off the chart. But you want to organize it in such a way so that you'll know what's going on. Okay, so what I'm going to do is rewrite this whole expression with our factored form, and then take a look at what we need for our common denominator. Okay, so this will become 3x over, and I'll just make this a little bit bigger. So this will become 2x minus 1, 2x plus 1, plus 5 over, okay, this is going to be pretty big, x parenthesis 2x minus 1. And then the last one, 2x plus 1. And again, every time I see a binomial on a fraction, I like to put parentheses around it. You could technically put parentheses on all of these. It just helps when it comes to multiplying things out and you don't make a mistake. All right, so what's underneath 2x plus 1? We have 2x plus 1 and x plus 2, right? Okay, All right, so here's our three fractions. Here are our three fractions. And let's see, what do we need? Well, okay, we want to make the denominator look exactly the same. So these two guys lack x and x plus 2. Does that make sense? So 2x plus 1 is found here. So this will need an x and an x plus 2, meaning basically put whatever you don't have with regards to everyone else. So I'm going to do this. I want to put here x and 2, no, x plus 2. And whatever you do on the bottom to make it into a common denominator, you do it to the top to maintain equivalent fraction. Okay, I hope that made sense. So what do we need right here? Well, we have an x and 2x minus 1. This guy's a 2x plus 1. He needs that too. So whatever you're lacking, okay, so 2x plus 1. And it's lacking x plus 2, right? So we want to put x plus 2 here. So 2x plus 1, x plus 2. Now the last one, you have a 2x plus 1. You have that here. X plus 2. Let's see. So from the first group, he needs a 2x minus 1. So I'll put that there. 2x minus 1. Does it have an x? No. So we put an x right there. Oops. All right, so we have 2x minus 1 and an x. And let's just double check everything. Do we have 4 factors and are they all the same? We have x, x plus 2, 2x minus 1, 2x plus 1, x, x plus 2, 2x minus 1, 2x plus 2, check, x, and x plus 2, and the rest. Oh, I keep getting screensaver. All right, so now combine the fraction into one big fraction with one denominator. I hate this. X, 2x minus 1, 2x plus 1, x plus 2. And then the numerator, again, don't multiply it out right now. I know it's going to be an extra work, but better safe than getting that B minus or B plus because you couldn't get that A, or, you know. All right, so 2x plus 1, 2x minus 1, and x. Okay, I'm going to stop here. This is your job. You're going to multiply this out, okay? I have some more stuff to discuss. So, okay, so yeah, just basically just multiply everything out. Well, this separately to that, and then add it all together and state your excluded values and you're done. Okay. Okay, now let's move on to a different type. Now here, you're thinking, what is that? Well, it's basically a fraction on top and another fraction on the bottom, but you're not adding. We're just basically trying to simplify. Now again, all the stuff that we're doing here in Algebra 2, we've done it at some point in our life in either 5th grade, 6th grade, 7th grade, Algebra 1. And let me show you. Do you remember when you were a young hog, something like this, 1 over 3 over 2/7? Okay? It's called complex fractions. It's just, it's basically a numerator, which happens to be a fraction on top of another what? Fraction. Now, you need to understand this. In order to actually solve this or simplify this, you have to have one fraction on top and one fraction on the bottom to do something like this. This is technically 1/3 divided by 2/7. Does that make sense? And do you remember your teacher telling you take the second fraction and you flip it? I think they used to think something like keep, flip, change. So you keep the first one, you flip the second one, and you change the sign into a multiplication and you multiply it out. 7 over what? 7 over 6. Okay, now that's the traditional way. You can always do that, no problem, but there is a shortcut, and this is pretty cool. And again, I'm going to show you something interesting here. Now again, so every time you get stuck with math, you really got to go back to your basics and ask yourself, am I following this procedure, this conceptual idea with something simplified, something very simplified, so that when I come to something complex like this, I kind of know where to go. So I'm going to show you how this literally is no different than the numbers that we're working with. But again, let me just finish this illustration here, okay? So this is the traditional way, right? Numerator divided by the denominator, and you use the division symbol, change it, flip the second one, and then you just multiply straight across. You get 7 over 6. Watch this. You have 1 over 3 divided by 2 over 7. Now, I'm going to use the number 1 again, and you're going to see this a lot, okay? Can I multiply mathematically? Can I, okay, multiply 1 at any time? And the answer is absolutely, okay, absolute yes, because it doesn't change anything. So now the question is this, well, what am I going to use for that number 1? You can use what? 7 over 7, 8 over 8, happy face over happy face, everything equals 1. So the question is, what 1 should I use so that this thing becomes easier? Well, it turns out, let me erase all this. Look at the denominator of the top and the bottom. Now I know 2/7 is technically the denominator of this whole fraction, but let's look at it individually. Look at the numerator. The numerator's denominator, which is 3. The denominator's denominator, which is what? 7. So take a look at those two, right? Ask yourself, what's your common denominator? Like if you were adding 1/3 plus 2/7, what would be your common denominator? It would be 21. Or how would we turn them into common denominators? Well, again, if you have a 3 here and 7 here, the 3 needs a 7, so I'm going to multiply 7 over 7. Whoa. But I'm not going to do it that way, actually. Let me scratch that. I'm just going to multiply. Okay, I wish I can read. I'm not going to edit this, so just scratch that. The common denominator is 21. So get that denominator and just multiply the top and the what? The bottom. What's 21 over 21? Well, if you write it like that, it equals 1. I mean, if you cancel that out, it'll just go right back to the original. But instead of doing that, watch what happens. When you multiply this across, can you simplify the 3 and the 21? How about the denominator? Cancel that out. 1 and 3. 2 times 3 is 6. I should hear some gasping now. Okay. Now you might ask, well, both look about the same amount of work, but when it comes to these expressions that we're going to try right now, it's going to be slightly faster and less complicated in terms of working it all out. But what's the point? Okay, so the point is this: you have a complex fraction, and you're not adding or subtracting anything yet. But when you have a numerator and a denominator, and both are fractions, you're going to have to simplify it so that at the very end you have a simplified fraction with just one denominator and one what? I'm sorry, one numerator and one denominator. Okay, so let's try to apply what we learned right here with multiplying by, the common denominator on top and bottom with this. Now, again, the traditional way, I don't know why I keep saying the word traditional, but normally I would do something like this when I was young. X minus 3 over 3, x minus 3 over 1, and get common denominator. See that? You can do that, but we're not going to do that. What we're going to do is this. X over 3 minus 1 over x minus 3. Now again, put a parenthesis on top and a parenthesis on the bottom, and make the denominator, if you don't have like a fractional expression, turn it into a fraction by putting it over 1, and this is going to help. So as I said before, look at the numerator's denominator, right? The guy on the bottom, or right here. That's a 3. What about this guy? It's a 1. So we're going to stare at 3 and 1. And by the way, this 1 right here, you can obviously rewrite that as 1 over 1. So, there's a 3, a 1, and a 1. So if you take a look at all three numbers, what's the common denominator between 3 and 1? It's 3. So we're going to use 3 and just multiply top and what? And bottom, like straight through. Okay, or distributive property. This times that, and again, this times that. Well, actually, hold on. This is just one expression, so we'll just multiply straight across. Okay? So again, 3 over 3 technically equals 1. So we're multiplying by the number 1 using the identity property of multiplication again. But watch what happens when you multiply 3 and distribute it. The denominator cancels out. Right here. X over 3 times 3. You can actually cancel out the 3 and the 3. And it's gone. And all you have left is the letter X. So X. And then 3 times 1 equals what? 3. Look at that. No more denominator for the numerator, or it's not complex anymore. 3 times the bottom. Now here, the denominator, as I told you, don't multiply it out. Always leave it in its factored form. So this will become 3 parentheses x minus what? 3. And you're wondering where's that 1? Okay, it's right there. You don't have to always write that. And guess what? The numerator, you can always put a parenthesis. You have like terms or like factors, and you can cancel that out. And your final answer is 1 over 3. And there you go. Okay, let's try it again. Look at let's see, where's my next one? Okay. So again, on the top, you have complex fractions, and on the bottom, you have one expression, but let's turn that into a what? A fraction. Okay, so look at the bottom of each fraction. So look at the top, look at the bottom of the top. Okay, so there's one on top. X and Y are its denominators. The common denominator for both of those is X and Y, but we also want to combine it with the one on the bottom. So it's easy. If it's just 1, it'll just be X times Y, right? So I'm going to multiply the top by the common denominator and the bottom with the common what? Denominator. So basically find the common denominator and multiply the top with it and the bottom with it, like straight across in a distributive property situation. So, all right, now we're going to do this in our head, okay? Because we're going to multiply xy first to the first fraction right over here. Now, if you multiply 1 over x times x over y, okay, now, if you have a hard time seeing this, I'll just kind of write it separately right here. 1 over x times xy, what will cancel out? You can cancel out the 2 x's, and all you're left is with the y. Does that make sense? Okay, what I did here is what's going on. Oh, actually, maybe this might help. If I make this gold, and this right here is 1 over x. And if I multiply those two together, you cancel out the x, and the answer is simply what? Y. So if I distribute x and y to the first fraction, you can cancel out the x's. All you'll have left is the letter y right there. And then plus, because there's a plus sign, and then you're going to distribute xy to this 1 over y, and what will cancel out? The 2 y values, and the x will stay by itself, or x will remain. What about the denominator? Again, as I told you, do not multiply the denominator out. Always write it in its multiplied form or factored form. So what you have here is parenthesis x plus y times xy. Now again, you can put it here or you can move it to the front. You can always switch the order. And guess what? If you put a parenthesis on the top, you have the exact same factors. I know it's out of order, but x plus y is the same thing as y plus x. Cancel and what? Cancel, and your final form is 1 over xy. Let me take a step back because I forgot to do something. Now, I know your teacher might say as you do complex fractions, you don't need to write your excluded values, but you want to get into a habit. You want to get into the habit of always writing your excluded values first anytime you have a denominator with variables. So here, x cannot equal 0, y cannot equal what? 0. And over here, there's no need to worry about this one. Well, actually here, right? If you put x equals 3, 3 minus 3 will be 0, and you'll get a 0 here. So x cannot equal what? 3. For this one, you don't need to worry about that because it's just a number. Okay? All right, but again, always get into the habit, because in the future, the teachers are not going to ask for it. They're going to expect it in your answer if you work with rational equations or rational expressions for that matter. Okay, so let's try this one. I know you look at this and you're like, oh my goodness, what in the world? Well, again, you basically have a fraction minus a fraction over another what? Another fraction. Okay? I don't know. I thought it was like a happy face. So fraction over fraction, fraction minus fraction over another what? Fraction. And then you look at the denominator right here and you realize, oh, isn't that difference of squares? Yes. So what you have to do is you have to factor that out. Okay, so but let me take it slow. I'll take it slow so that you don't get, like a brain freeze or something like that. All right, so let me just kind of rewrite it in a more, I guess, I don't know. Maybe it'll look more comfortable, like 3 over parenthesis x minus 2 minus 4 over parenthesis x plus 2 all over 7 over, now I'm going to factor this out, x plus 2, x minus what? 2. Okay. All right. Now, I'm going to put a bracket, because what am I going to do? I'm going to find the common denominator for the fractions on top and bottom and multiply everything with it, and hoping that it'll just start simplifying out. This is x minus 2, this is x plus 2, this is x plus 2, x minus 2. What's our common denominator if we happen to be adding all three of these? Well, it'll be these two right here. Okay, so we're going to multiply the top with the common denominators that we find here. So x plus 2, x minus 2, x plus 2, x minus 2. Now some teachers, again, put that on this side to show that you're distributing. Totally fine. Doesn't matter which side you multiply it in, but you want to get used to, multiplying it on the right side or the left side. Okay, so let's take that and distribute it here. Okay, so try to do this in your head. That times this. This is your numerator. That's your numerator. This is your fraction. And what's going to happen with the x minus 2's? It will cancel what? It will cancel out. So if I did it like this, it will go like this. See that? And all you're going to multiply is 3 times x plus 2. So I'll put it right here. 3 times x plus 2. But now I get to erase all this, because while I've crossed out x minus 2 for the first fraction, I have to use the exact same to distribute to this fraction as well. So you're not canceling it out, meaning I canceled it out for the first one, but it doesn't mean that it's canceled out for the second one. You have to redistribute the original common denominator. So if you distribute this to this fraction right here, what cancels out? Well, in this case, the x plus 2's will what? Cancel out, and you're left with, now don't forget, -4. Okay, don't forget that negative sign. So it'll be -4 parenthesis x minus 2. Okay, got it? All right, what about the denominator? Let's take a look at the bottom. Well, guess what? These two are the same. Can we cross both of them out? Yes, and guess what? All we have left is the number 7. Okay, now this is easy. Okay, oh, I totally forgot. What's our excluded value? X cannot equal 2 or -2. Okay, all right, so here just multiply out the top. 3x plus 6 minus 4x plus 8 all over 7. So 3x minus 4x is -x. 6 plus 8 is plus 14. And voila, there is our simplified fraction. So all of that became this. Okay, so I think that's it for our complex fractions. Okay, fine. There's one more. Hold on. Which one's it? Okay, I'll just give you this one too. All right, I'm getting hungry, so I'm gonna have to stop soon. My stomach is growling right now. Okay, so what do we do here? Now you're thinking, oh my gosh, what's going on here? Same procedure, same concept. Here, just imagine this to be over what? Over 1. And on the bottom, over what? Over 1. I need a common denominator of all the denominators for the top and the bottom. So the denominator of the top is this guy, and the denominator for the bottom is this guy. What's our common denominator between these two? Now keep in mind that even though this one looks the same as this guy right here, he's a numerator, so we don't have to worry about him. This is the denominator, this is the denominator. What's our common denominator? Okay, so what we're gonna do, again, I'm gonna use a bracket like that, and I'm going to multiply everything by square root of x squared plus 2 on the top and the square root of x squared plus 2 on the bottom. Whatever you do to the top, you must do it to the bottom. Okay. All right. Now I'm going to work with the bottom first, just to get it out of the way. As I told you, you're going to multiply x squared to this. Just write it like that. X squared times x squared plus 3. Now again, you cannot take a number on the outside and just distribute it inside a radical. It's just leave it like this. Now the top, what happens? Well, try it again. Focus. This one times that one. Okay, so again, this is like over 1, right? So when you multiply two fractions, if the numerator on one fraction and the denominator on the other fraction is the same, you can cancel it out. So you can go like this. Cancel and cancel. And all you have left is an x what? X squared. So you could put x squared right here. Now, I'm going to erase this because, again, as I told you, just because you cross it out on the first try, you can't do it. You can't just, you have to reuse that because we're distributing. We're going this times that times this times what? That. Now, what happens when you multiply two exact same radicals? You get the expression without the radical. And again, don't forget this negative sign. It's so crazy, right? This is where everyone makes their mistake. So you put the negative sign right there. And the expression is just x squared plus 2. Now notice, if I write it like this, only the x squared is negated. So you have to put a parenthesis because this right here is a single entity. So when that square root symbol comes off, boom, you put a parenthesis there, okay? But if this part is confusing you, so let me just do it right here. So square root of x squared plus 2 times the square root of x squared plus 2. As long as they're identical, the square root just comes off, and the answer is x squared plus 2. And now again, just for the sake of consistency, I'm going to put a parenthesis here, okay? Now if you're thinking, I still don't get that, well, look at it like this. What's the square root of 7 times the square root of 7? It's just 7. Well, technically it's square root of 49. Square root of 49 is equal to what? 7. Okay, what about square root of p times square root of p? It's technically square root of p squared, which is simply what? P. So you can skip the middle step as long as they're exactly the same. Okay, square root of x plus y times square root of x plus y, you get x plus y. Okay, all right, so what do we have? We have this. Now distribute the negative sign. So we got x squared minus 2 over x squared radical x squared plus 3. The x squares cancel. Wait. Oops. See, I'm going delirious now. Okay, because when you're hungry and doing math, it's not good. X squared, square root of x squared plus 3. Okay, so now when you finish it off, wait a minute. Did I start with the excluded value? I keep forgetting. Oh my God, I keep telling you guys. Oh, well, obviously here, you don't want it to be 0, but x squared will never turn to 0. So there's no excluded values. Oh, except for this guy right here. So x cannot equal 0. And here, yeah, when you have an x squared plus something, it'll never turn to 0. You just have to worry about that guy. X cannot equal 0. But again, I think your teacher will say, for these types of problems, you don't need to write the excluded value, which is fine. So make sure you just read the instructions carefully for your exams. Okay, now just some other stuff. Now again, this one, you're like, oh my gosh, what's that, -1? It's just another way of writing a number. So like if I had 1/5 and I didn't want 5 on the bottom, okay, and by the way, all numbers have a 1 as their exponent. If you take that 5 and move it to the top, the exponent changes signs. It becomes 5 negative 1. So 5 negative 1 is technically the same thing as 1 over what? 1/5. So if you have 5 negative 1, you write it as 1/5. If you have y negative 1, you write that as 1 over what? 1 over y. If you have like y squared or negative 2, you write it as 1 over y positive squared. So you just write this as 1 over y minus, now if you have a parenthesis to negative 1, that whole parenthesis, you have to treat it like one number. It'll become 1 over y plus 5 to the first power. Now, you don't have to write that 1 there, but just to make it clear, that negative 1 becomes positive 1 as the whole parenthesis comes to the denominator, and this is over what? 5. So what's your common denominator? Well, the denominator for the bottom is 1, so you don't have to worry about that. The denominator for these two, the common denominator is y times y plus 5. So we're going to take the whole expression on the top, multiply that by the common denominator, which is y parenthesis y plus 5 on the top and the bottom. Okay, so now you go this times that, or you're going to distribute this here. The y's should cancel out, right? And you'll just have y plus 5 left. And again, don't mess this up here. The negative sign right there. And then this times this, the y plus 5s will cancel out. You'll have y left over. Ta-da! There you go. And again, in the bottom, do not multiply it out. So you'll write this as 5 times y plus 5. So just write it as 5y, y plus 5. And the numerator, can you cancel anything out or simplify things or combine like terms? Yes, those two will cancel out. So you're left with 5 over 5y, y plus 5. And you cancel out the 5s, and you have y plus 5. Oh yeah, y cannot equal 0, y cannot equal negative 5. I should have started off that first. Y cannot equal 0 here, y cannot equal negative 5 up there, okay? All right, so that'll be it for our expressions. I hope that'll help you for the test. On my next video, actually, what did I say in the beginning? In the beginning, I said that I'm going to do what? All three? Well, I ran out of time. So we spent most of our time with this one. So on my next video, I'll cover the second one and the third one. Okay, have a good night.